Welcome back, everyone. We're going to continue with our discussion about triangle congruence. In our most recent videos and lessons, we've talked about two postulates and definitions that have proven that triangles are congruent to each other. Our first, the way we started the unit, was the definition of congruent polygons. Remember, the definition of congruent polygons told us that if all of the corresponding angles and segments or side lengths in a pair of triangles were congruent to each other, then by definition, the triangles themselves had to be congruent. After going through that definition and proving some triangles were congruent, we moved on to a postulate called side-side-side. If you know that all three segments of a triangle of two triangles were congruent to each other, then by the postulate, the side-side-side postulate, those triangles had to be congruent to each other regardless of the angle measures. And then it just follows that the angles have to also be congruent. Well, today we're going to explore another case. I have a bit of a starting point for two triangles here, triangle ultimately ABC, triangle DEF. These two startups are the same, and to prove that, you could look in the margin here. We have measures for the lengths of certain sides. Segment AB is 3.79 units, while segment DE is 3.79 units. So what we would say then is that segment AB is congruent to segment DE. Same goes for BC and EF. If you look at the margin there as I click these, they are both 5.04 units in length. So what we can say is that segment BC is congruent to segment EF. Lastly, we have a pair of angles. Angle B is 34.89 degrees. Angle E, labeled as beta because of this program, is 34.89 degrees as well. Angle B is congruent to angle E. So what are we really starting with here for our two perspective triangles? We are starting with a case of having two segments in triangles being congruent and the included angle being congruent as well. The included angle is the angle that is created when a pair of sides meet at a point. So segment AB and BC are meeting at point B. The included angle is the angle that's created by those two segments. The pattern we're looking at for both of these triangles would be dubbed side, angle, side, with the A being between the two S's. Both of these startups or triangles are starting with a congruent side, angle, side pattern. So the question we're hoping to answer now is this startup for both triangles enough to prove that the resulting triangles have to be congruent? Well, there's only one way to create a pair of triangles here. We have to finish the triangle out with a line segment. So I'm going to connect the points AC, connect the points DF. Segment AC, also dubbed I here, is 2.9 units, and segment DF is 2.9 units. Segment AC is congruent to segment DF. So far we have all three segments being congruent. The only thing we would really need to want to show now is to show that the angles that resulted are congruent as well. So we're going to go ahead and do that. We're going to select this angle by going like this. All right, we get an angle here. We'll do the same over here. Angles A and D correspond to each other. They're congruent. Angles B and E correspond. We've already talked about how all the sides are congruent. 48.3 degrees. And 48.3 degrees. Obviously, by subtraction, we knew the third angles were congruent. We've discussed that in class. But we have a pair of triangles that started with that side angle side pattern where the two sides were congruent and the included angles were congruent. The resulting triangles that are created from those two starting points have to be congruent. So what did we just prove? If a pair of triangles have two sides that are congruent and the angle in between, or the included angle, if they meet the side angle side pattern, that means the triangles must be congruent. There is no way to complete a pair of triangles that have that pattern without the resulting triangles be congruent. So we are now adding an additional postulate to our bag of tricks. We've discussed the definition of congruent polygons as like the big overarching idea. And now we have the side-side-side congruence postulate that proves that two triangles are congruent if all three sides are congruent. And we have the side angle side congruence postulate, which proves that two triangles are congruent if they have two sets of corresponding sides that are congruent and the included angle between them also happens to be congruent. Thanks for watching.